Hi guys, welcome back to day 2 of me teaching you earth science from home. So we're going to continue on with weathering. Just a quick review of what we did yesterday. We learned that weathering is the breaking down of rocks into smaller particles. And there's 2 types, physical and chemical weathering. And then for each one of those, physical weathering, which does not change the composition of the rock, there are 4 different types of physical weathering, and they each have their own properties. And chemical weathering, which is the breaking down of rocks by changing the chemical composition, there's 3 different types of chemical weathering. If you missed yesterday, whether you were absent or didn't know what was going on, that video from yesterday is still posted. You can go back and fill that in. Those are pages 1 and 2 of the packet. We're actually going to finish up page 2 right now. So we have some factors that affect weathering. And the first thing that we want to talk about is the composition of rocks. So as we learned in chapter 3, some minerals are harder than others. And remember, hardness was how easily scratched the mineral was. So in other words, some minerals can break down a little bit easier than others. And some rocks are harder and some rocks are softer. There's lots of different factors that affect how fast a rock will weather. What we're going to look at right now is the composition of the rock. So mineral composition, this is going to go right on the bottom of page 2, right next to that you have the same picture in your packet. So we're going to be talking about mineral composition. So label mineral composition at the very top of that, and we can see that weaker, less resistance rocks weather faster than any other. In this diagram, layer A, you can see layer A has been worn away more than all the other layers. So that's the layer that's less resistant. I want to talk about that word resistant. First, I'm going to give you a second to copy this bullet down. So go ahead and copy this onto page 2 of your packet. Like I said, I want to talk about this word less resistant. It's a phrase that the Regents loves. I've mentioned this before, that the Regents sometimes uses words that I feel like they just trying to sound smart and fancy, but they could have used way easier to understand words. So less resistant. If you think about it, when you hear resistant, what does that sound like? So I personally think resistant reminds me of resist. And you most often hear of resist, like if someone's resisting arrest, what are they doing? They're fighting being arrested. They don't want to be arrested. So the more resistant, the harder they are to arrest. The less resistant person is easier to arrest. So it's similar with rocks. If they are more resistant to weathering, that means it's harder to weather them, so they don't weather as easily. But less resistant rocks, they weather very easily. They just get broken down really easily. So you can see here with these layers all, and maybe that was another thing I should have talked about first, these layers would have all gone all the way across the paper here. So they would have all been pretty much the same size as D. But you can see that A has been worn down quite a bit, and that's because A is made out of shale, and shale is a very weak rock, so it's less resistant to weathering. That means it lets weathering happen very easily and means it gets worn down easy and fast. Sorry about that. All right, so we're gonna go to the top of page 3 now. And on the top of page 3, you're just gonna see a chart that's gonna have physical weathering on one side and chemical weathering on the other. On this, we're gonna put the important facts. So for the first one, we're gonna talk about climate. What affects weathering rates? And we're gonna start with climate. We already did take these notes yesterday for what affects what climate these happen the most in. So we'll start with physical weathering. If you flip back to page 1, you can find the type of climate that physical weathering likes. So flip back to page 1 and find that climate. You'll find it right, where is it? It's right in the physical weathering spot right next to those broken rocks. You can see there, it says happens more in cold, moist climates. So in the box underneath physical weathering for climate, you're gonna put cold and moist. So we need the moisture. So we need water for all 4 of those different types of physical weathering. You need water. And we do see more physical weathering in areas where it freezes and thaws a lot. So we need that cold weather. Now onto the chemical side. So just flip back to page 2. We said there underneath chemical weathering that it happens more in warm, moist climates. Warm and moist, so somewhere chemical reactions tend to happen faster in warm water. Think of if you've ever tried to dissolve like sugar. Sugar in ice water takes a lot longer to dissolve than if you were to put like sugar in your coffee or sugar in hot tea. It just dissolves faster in warmer water. And the same happens with most chemical reactions. They happen more in warm climates. So again, here it would be some examples. You can see that what I was trying to show here is the moisture level. So in a dry climate, not much is going to get worn away, not much is going to change, but in the warm, moist climate, we'll have lots of weathering. Surface area. So we talked about surface area. This is also called exposure. So we mentioned yesterday that physical weathering creates more surface area where weathering can occur. So go ahead and write that in. And I know I talked a little bit about this yesterday. I was actually looking for, oh, not okay, sorry, not there yet. In chemical, if you remember what we mentioned yesterday, that chemical only occurs on the surface where the rock is exposed to water and air. Again, you see this on a car or on any metal that you might leave outside and it gets rained on, that the rust is only on the outside where it's exposed to the air and the water. It's actually why we paint cars, not only to look nice, but to protect the metal underneath them. You don't have rust until that metal gets exposed. So go ahead and for the chemical, go ahead and add that in. Okay, so this is the picture that I wanted to show you yesterday. I don't remember if you remember, I flipped through the slides and couldn't find this picture. This picture goes along with the physical weathering creating more surface area. So in this block A, if I asked you where the surface of this rock was, you would only be pointing to the outside. So this front, the top, the side, and of course the sides we can't see. But the surface of this block is just on the outside of the block. But when we break that rock, just like physical weathering does, it just breaks the rock into smaller pieces. Now we have more spots where the air is touching. In the end, the block is there's the same amount of block, but more of the inside, what was on the inside is now exposed to the air here in B. Again, I related this to crunching up a hard candy. So if you have a Jolly Rancher in your mouth at the start of class, it takes you a while, if you don't crunch it, to get rid of that Jolly Rancher. But if you crunch up the Jolly Rancher, even just a couple times, the pieces will dissolve faster than the whole one. And that's because there's more spots for your saliva to touch that Jolly Rancher. So there's more surface area once something's crushed up. And again, chemical and physical weathering go hand in hand here, because once it's broken up into pieces, now there's more spots for the air to touch. If this was a metal block, in block A, the only place rust would be on the outside of the block. But now when you cut it up like this, yes, there'll still be rust on the outside, but now we can get rust on this new outside pieces than what used to be on the inside. So there's just more spots for the chemical reaction to happen on. All right, and the last one is composition. For physical, weaker, less resistant rocks weather faster, they break easier. And then for chemicals, the rocks made with calcite will actually weather faster because again, calcite dissolves with acid. So go ahead and get that in those two bullets into your notes under physical and chemical. So that's actually going to be the end of the notes for now, but this does not mean by any chance that you're done for the day. What I want everybody to do is turn to page 5. On page 5, you have the compare and contrast for chemical and physical weathering. So this is the two weatherings that we just talked about. So on page 5, what you're going to be doing, actually, let me see if I can pull this up. One second, I'm having trouble here. Okay, so like I said, we are on page 5, and this is what you're going to spend most of the rest of the period working on. Is I would like you to do this compare and contrast for physical and chemical weathering. So what I'm looking for you to do, and you're going to use your notes to do this. This is just where you're writing down, you're basically summarizing chemical and physical weathering. So I want a quick definition for both chemical and physical. I'd like some types. And like I said here, I want you to include a quick description of each. So you'll notice I didn't give you much room, but I do want a little bit of a definition. One word is fine if that works. And then some factors that affect it. I do want you to continue on today with similarities and differences for each. And yes, I do want you to answer these 2 conclusion questions. I will be posting an assignment where you're going to go ahead and list some similarities and differences. That will be in the assignment section on Team. So you're going to spend the rest of the period working on that. And then when you're done, you will have homework tonight, and that is the questions on pages 3 and 4 of the packet here. I will remind you that the things that we learned previous to now are still fair game. So for example, what I'm talking about is here. It's talking about hydrosphere, lithosphere, mesosphere, thermosphere, hydrosphere, atmosphere, lithosphere, atmosphere. You need to remember what those words are. And we learned those, we learned a little bit of them last chapter. And then we also learned, I believe it was in chapter 1, what some of those words were. These symbols here, you'll find those on the rocks and minerals chart on page, I'm sorry, just the rocks chart on pages 6 and 7 in your packet, your reference table. Oh my gosh, it's been too long. The only one that's not there, and I'm not sure why they included it, is this little V's. I guess actually I know why they included it now that I'm looking at the question more. You don't even need to know what the names of these rocks are. You just need to be able to label which one is least resistant. So again, that's how the Regents is going to use this phrase. Least resistant means weathers easily, lets the weathering happen without putting up a fight. So that, again, your homework will be questions 1 through 9, I'm sorry, on this page 3 and 4. I'm going to post an assignment. The assignment's going to be graded. And you have to, how I'm going to work it is similar to how I know other teachers work it. I'm going to ask that you get at least a 65 to receive full credit on this assignment. So you will have to answer some of the questions correctly, but not all of them to receive credit. So that is the homework. And again, you are going to be working on this compare and contrast, which there's going to be some questions on the homework that go along with this. So and that'll be an assignment posted into Teams. All right, if you have any questions, again, you can message me on Teams. This will all be posted there, so you should have no problem going back and looking through it if you don't understand. And again, message me if you need anything. So tomorrow we'll start erosion. Today you're working on pages 5 and 6 first, and then going back to 3 and 4 for your homework. See you guys.